Hello, so for the last lesson of Unit 4, we will be solving linear systems, and we will go into depth as to what this means. So a linear system is a set of two or more linear equations that are graphed simultaneously. Simultaneously means at the same time. Now, the point of intersection is the point where these two lines cross, or where they intersect. A solution to a linear system of two equations is a point or a set of points that satisfies both equations. So it satisfies both equations. Now, there are three different types of solutions. In the first example, if we have two parallel lines, then these lines technically will never meet. And if they never meet, then there is no point that satisfies both equations. Therefore, there is no solution. So when the linear system involves two parallel lines, they do not cross. If we have two non-parallel lines, which is what we are going to see most often, then these lines intersect at only one point. So it only crosses one point because it can't go back and cross again, otherwise it would not be a straight line. So this one point, which is the shared point between both lines, this is the only solution, and this one point satisfies both equations. Now, if we have two identical lines, although these equations might look different, 2x plus 3y equals 6 and 4x plus 6y equals 12, they describe the same exact line, and I'll prove that in the following slide. And all points on one line will satisfy the equation of the other. So there are infinite number of solutions. As you can tell, I'm just gonna break these down into slope and intercept form so that you can see what we mean by saying that these are the same lines. So the first one, after we reduce it, we end up with y equals negative 2/3 x plus 2. And then for the second one, we end up with, again, after we reduce it, y equals negative 2/3 x plus 2. So these are two different lines that both share the same exact graph, so there are infinite number of solutions. Now we want to determine the solution to a linear system graphically. In the future, we're going to be solving them using numbers and algebraically, but for now we'll focus on solving them graphically. Then we want to verify our solutions by performing a check. So by performing a check, we're going to plug in the solution that we found into both equations and then seeing if it is consistent or if it satisfies both equations. So we begin. One way that we want to graph this line, since it's in standard form, is that we want to reduce it to slope and intercept form. So we do it like this, and we end up with y equals 1/3 x minus 2. Now, assuming that every point here is a unit, then y equals 1/3 x minus 2 means we're going to start at minus 2, and we're going to rise by 1 and run by 3. Rise by 1, run by 3. So we'll end up with a line like this. Then we can graph the other line, y equals negative x plus 2, which means we are going to start at 2 and then just go down with each box. So 1 unit to the right, 1 unit down, 1 unit to the right, 1 unit down. So you end up with this. Now, we can see that there is indeed a point where these two lines intersect, and it's right here. And this is called the point of intersection. This point of intersection is the point 3, negative 1. So we want to now verify if this solution satisfies both equations. So we check by plugging in 3 and negative 1 as our xy values into both equations, and we see what we get. So over here, if you can see, we plugged in y equals negative 1 and x equals 3. So 3 minus 3 times negative 1 minus 6 well, there's two negatives, so it becomes 3 plus 3 minus 6, and that becomes 6 minus 6, which is 0. And on the right hand side, as you can tell over here, we have equals to 0. So we can say that these two are the same, and the left hand side equals the right hand side for this equation when we plug in our point 3 and negative 1. Now for the second equation, we have again our point 3 and negative 1, and so we plug this into our equation to verify if it is satisfied. So we have negative 1 over here, we replace y with negative 1, and then on the right hand side we're going to do negative x plus 2, where x equals 3, so we have negative 3 plus 2, which is negative 3 plus 2, which is negative 1. Therefore, since negative 1 is equal to negative 1, then we can conclude certainly that the solution is 3 and negative 1. Now we have two other equations, and again we're going to reduce the first equation into slope and intercept form, and then we are going to graph it. So what we're doing here is that we're starting at 3 and rising by 2 and going to the right by 1. So 2, 2, and 2, 2, 2. And then we have this line x equals negative 3. X equals negative 3, we know this is a vertical line that crosses x equals negative 3 right here. Right here. So we plot it, and then we notice that there is indeed a point at which these two lines intersect. So this is the point negative 3, negative 3. And now again we want to check if this point is actually satisfying both equations. So we start. On the left hand side we have negative 4x plus 2y equals 6. So on the right hand side we'll have 6. And we can replace negative 3 into both, and then we'll end up with 12 minus 6 equals 6. And since 6 equals 6, then this satisfies this first equation. Now we have a vertical line, and we want to replace with our values. Since there is no y value in this equation, then we just have to replace the x value with negative 3. And since negative 3 equals negative 3, then we can conclude that yes, this does indeed satisfy the second equation. And since the right hand side equals the left side in both equations, then the solution is indeed negative 3, negative 3. Now, example 2, we have two banquet halls that are offering to host a wedding. The first hall, which we'll call Hall A, charges a fee of $1,000 up front and $20 per person. The second hall, Hall B, charges a fee of just $30 per person. Now, we want to write an equation that represents each of the options described above. So, let's just first label our variables and what they mean. So fee of $1,000 up front means it's our fixed fee, and $20 per person is our variable cost. And then just a fee of $30 per person, that's the variable cost for Hall B, and there's no fixed fee. So we define our variables. Let C be the total cost and let N be the number of people. And then we get Hall A is this equation, Hall B is this equation. Now I'm a professional pianist. I've played at a lot of weddings, and if a wedding venue is giving you these rates, you take it and run very far, very far. Normally they charge like $100 per person. So we want to graph the relations on the same set of axes. So since we're dealing with both a small and large number, so 20 and 1,000, it will be difficult to graph this, so we need to figure out 2 points for each equation algebraically before we can graph it. So I'm gonna pick the first point, which is n equals 0, because that's very easy. I know that this is the y-intercept, and I know for Hall B the y-intercept is at the origin because it's a direct variation. So then we just have to find it for the point 50 for both equations. So if we invited 50 people in both halls, how much would it cost? For hall A, on the line for hall A, I can tell that there's going to be either $1,000 for 0 people or $2,000 for 50 people, right here. And then for hall B, I know that it's going to be either $0 for 0 people or $1,500 for 50 people. So we can graph this on this line. And as you can tell, we graphed our first line of 0 and 1,000 and 50 and 2,000, and we just connected those 2 points and extended the line further out. And then for hall B, we did the same thing, the origin and 50 and 1,500, and then we connected these 2 points and then extended it out. Now we want to identify the point of intersection. So the point of intersection is right here. It's right there. It's very easy to locate. And it is at the point 100 and 3,000. So what does this mean? That means that if we were to invite only 100 guests, then it wouldn't matter which hall we picked. In both halls, it would cost the exact same amount, which is $3,000. So, having said this, how would we advise someone who is trying to choose a hall? So, if they wanted to invite fewer than 100 guests, then it is in their best interest to go with hall B because it costs the least, or it'll cost less. Now, if they want to invite over 100 guests, then hall A is going to be the more affordable one. It's going to cost less than hall B. For example 3, we have 2 payment options for downloading a movie from a website. We can pay $30 for a membership and then $2 per movie downloaded. Or we can use this line that's on the grid right here. So first we want to graph option A. So we can graph this right away. We're going to start at $30 and then we're going to go up $2 for every unit for every movie bought. So we can graph this like this and pay close attention to the axes and how they are numbered. So over here on the horizontal axis, every 2 boxes we increase the number of new movies by 1. Whereas over here, every 2 boxes, we increase the total cost by $4. So, as you can tell, we have this graph over here, but we want to figure out the graph of this line over here. Well, we know that it's a direct variation because it goes through the origin 0, 0. So, we want to figure out the slope. In this case, the slope is a rise of 10 and a run of 2. I picked 10 and 2 because that's where it intersects with an actual grid line, so it's easy to read. Now 10 divided by 2 is 5, so option B will be C equals 5n. Now we want to determine under which conditions a person should select option A and under which conditions a person should select option B. So clearly option A and option B, option A is more expensive before we cross this intersection line, and option B will be more expensive after. So we want to figure out what this intersection line is. And we see it's right over here, and it is the point 1050. That means that if we buy 10 movies exactly, then it won't make a difference which option we choose because it'll cost the same. Now, then we can say then, if a person is planning on buying fewer than 10 movies, then option B is actually more affordable because it costs less than option A. Now, if a person downloads more than 10 movies, then option A will be the more affordable one. Now, how would our answer change if option B included a $15 membership fee? Well, the first thing that we need to notice is that a $15 membership fee is a fixed cost. So we can just add that $15 to option B's cost. That means that option B is now going to start at $15 instead of 0. So we draw it, and as you can tell, since option B has the same slope as before, it's parallel, right? Yeah, it's parallel, and it's 5n plus 15. And notice how after we shifted it up, the point of intersection changed as well. So now we have a different point of intersection, and it's the point 540. Now the point 540 means that if a person is planning on downloading fewer than 5 movies now, then option B will be more affordable. Okay. Now if a person is planning on buying more than 5 movies, is planning on downloading more than 5 movies, then option A will be more affordable. Before I end this video, this is a very handy resource. This is on GeoGebra. It's on the same website as yesterday's. I really strongly advise you to take a look at it, get familiar with graphing lines and identifying points of intersection or solutions. For example, this equation right here, it starts at 1, so let me just put it at the 1 at the y-intercept, and it decreases by 7 units, so it has a slope of 7, negative 7 I mean. And then over here, oh yeah, I have to kind of go lower. Over here it starts at negative 6, and it has a slope of negative 14, which means it's like this, because negative 6 minus 14 is negative 20. And then we can locate this point of intersection right here, which is at the point negative 1 and 8, which is correct. So it's a very handy resource. You can always test it out. It also gives you a good idea on how these things work. So yeah, give it a try. Familiarize yourself with this stuff, because this is going to be a very handy resource for you.